What's up? I'm Austin Griffith. I'm here with the Build Guild. We're guild building. We're building stuff. We're building stuff with Scaffold-Eth, etc. Building apps on Ethereum. We got a bunch of people to show off today, so we're just going to get right to it. I'll probably limit the. You may hear me going like buzz. That means like your time's up or something. We might have to figure out a way to limit time. But we're going to start with Bert. Bert, what do you have to show us? Take it away. Steal the screen and show us what you got.
Thank you. Yeah, let me just share my screen. We're going to get started with the front end. So this is just a simple application. Let me just hide the controls here. Yes, this is just a simple application for PetFundMe. Think of it as a GoFundMe, but this is instead of humans, this is a human pets. It's basically for pets who are homeless or for pet owners who are low income, and then they have to go through expensive surgeries and food supplies. I happen to own a pet, and I happen to know and volunteer sometimes, and it can be expensive. So I was just wondering, how can I help this community of pet lovers and pet supporters? And I come with this idea, PetFundMe. So this is basically a simple app, but I would like to make to bring this alive, this concept alive. And it's just something that I would like for social good. The way it works is that you can come here. You can either search for title name, and then you can see. As you can see, you can click on one. You will be able to donate. So let's just do that. Make sure you are connected. Right now, we are connected to the Matic Mumbai. But here, the idea is just to pass a number. So let's just suppose that we want to just add $1, or you can add $1 or whatever you want. Here we just have the message is working in the contract. I haven't implemented in the front end, so we can just say I hope this helps. Then we want to donate. We need to confirm for that. And then this is going to go through, the transaction is going to go through, and then we can go back into the post and see the amount going up to it. Let's just wait for a second. And while we wait, maybe we can just open a new one, and we can try to upload. Same for upload. You can come here and add an image here. Let's just add this. Let's just reuse this one. This is gonna upload it to IPFS. We have the URL for IPFS. You can get a title. We can say, please help. And we're just gonna reuse the description, and then we can have a target amount. We can just say we just want 1,000, and then you can have the category. I'm gonna use it for medical reasons, and then I can hit create, and then the same thing is gonna happen. You're gonna have a preview, and then you can confirm here. And then we need to connect our wallet first. We're just gonna do that. After that, we confirm. We're gonna confirm this, and then while we're waiting, we can go back to donate, and then now we can go to here, and then we're gonna see this, and then it was 6, we donated 10, and went up to 10. In the future, I would like to add to auto display this is a hard-coded image or an image, but I would like to have that. I would like to display the icon, the wallet, and then the amount, and then maybe like the message that it was sent. That's for donations. And then here in the future also would like some updates of this cat, how is it doing, and things like that. And for the upload, I think it has already been sent. And that should be the upload. Yes, so now we should get in five pets if we go home. Let's see. It might take a little bit longer because I saw that IPFS it was like slow. So let's just pretend that it's working. But yeah, we should be having five arrays this one. So it's just a matter of the IPFS getting back to us with the information here. What I have in the backend, I have a simple contract. I have a total fundraisers and total donations just to keep track of the donations and the fundraisers. And then so I have some events, but the most important for this is like when I create a fundraiser, I just pass the CID from IPFS, the target amount, and then I just set it to the fundraiser. And then the same for donate. I have the donate function. I have a way to get all the fundraisers as well as to get donations by fundraisers, and this will help us to get for every single post or fundraiser, we're gonna get all the donators for that, and then here we get just a simple get fundraiser one, and this is just to get one in case, and this is really helpful when you go to one post, and that basically is that. So this is what I have so far with PetFundMe, and yeah, this is what I have. Thank you.
Very cool. Yeah, if we were living in a society where the government decided you can no longer fund pets, that's the wrong thing to do, then you could deploy PetFundMe, and you could have a censorship-resistant pet funding platform. And this is a good hackathon build too, because it teaches you all the mechanics of talking to contracts and uploading to IPFS and a lot of other stuff. So good build, Bert. Keep going, keep building, keep shipping things like this. That's the best. Carlos says nice UI.
Thank
All
you.
right.
Thank you, guys.
Great build. I think up next is going to be ByteAtATime. ByteAtATime. Are you out there? You want to share your screen and hit us up with what you have? You'll see me doing this on the screen when we're running out of time. I won't do like a angry buzzer or anything, but you've got 3 minutes. ByteAtATime. What do you got?
All right. Is my volume good? Okay.
Yep, it's good.
All right. Can you see my screen?
Yep, we've got the UI on the right and the code on the left.
Yeah. Okay. So I spent some time working on a little app that shows you statistics for the amount of gas you spent. Because I usually work on Binance Smart Chain, which has relatively low fees. So with Ethereum, I was kind of surprised that like a swap costs like $10 just in gas fees. I'm not even swapping that much. So I was kind of intrigued by like how much are we actually wasting. So I made this little app. So for example, this is Austin's address on Ethereum mainnet.
Oh no.
So
I deploy a lot of
somehow I managed to
contracts.
spend 35 ETH, which is more than I've earned. And then this is a table that shows you the statistics. So by default, it's sorted by the amount, by the transaction fee, but you can also sort by timestamp, value, and stuff like that. So for example, if we sort by transaction fee, we can see that your highest transaction took half an ether, and then you can go to the page in Etherscan and you're spamming tokens or something. I don't know.
I don't know.
And
Maybe
this
that
also,
was at ETH Denver or something. We were giving out, it looks like I was giving out tokens at ETH Denver, or maybe it was like I did a presentation and I had everybody turn in their address and then I sent a bunch of Spork DAO to them. This was like back at ETH Denver and 2021 or something like that. Yeah, I don't know exactly what that. Oh no, that was at MCon. It was MCon 2021. Oh man, that's a lot of money.
all right. Well, you spent 1.6K in ETH on that day, just for fees. And then this also works with ENS, so Austin Griffith.eth. And it should show the same stats. Yeah. And then this also works in different chains. So Polygon, you've spent 2 Matic, so that's like $1.50, so not that much.
Cool, Bill. How do you parse this information? Are you getting all this information in the front end, or do you have a back end that's parsing through it?
So I built this using Svelte, so like it's basically backend. I tried to use like just normal like Web3 without getting Etherscan API, but apparently then I need to look through every single block from 0 to the current block to see what transactions you have. So that's just not really time efficient. So then I just used the Etherscan API.
Got it. Okay, Etherscan API. So you aren't crawling blocks. You just hit the Etherscan API and grab the info. Cool.
Yeah.
Awesome. Well, that's embarrassing. That is a lot of ETH. For what it's worth, like I probably didn't have to pay that. That was someone like giving me Spork DAO that I was to give out. Maybe I should hit him up for some transaction fees paid back. I also deploy like lots of contracts. Like every single person's BuidlGuidl stream is another smart contract that I deploy. Sometimes those go out and it only costs me $20. Sometimes those go out when the network's hot and it's like $100. So yes, I have some embarrassing transaction history. Good build though. Svelte. We don't see a lot of Svelte. So that was Svelte and then the Etherscan API, right? That was kind of the two main technologies there.
Yeah, I like Svelte because like it's basically just HTML. In React, there's a lot of like boilerplate and like kind of confusing code. So like you have to use state. In Svelte, it's literally just a variable declaration.
Awesome. Okay. Great build, ByteAtATime. Keep going. We need to get you over on Scaffold-Eth too. And off Binance chain. Boo. Oh, whatever. No, I ain't hating. If it's EVM compatible, I'm happy. I just haven't ever bridged over to Binance before. It feels a little murky over there. All right. Here we go. I think we got Codechef Song next. Codechef, what do you have for us? Probably a cute game, and I'm excited for it.
Okay. So share my screen. Can you see my screen?
We got it.
Okay, so yeah, so I built a simple game called Battle for ETH where players will fight each other for ETH. So what you see here is a field, and then you can like purchase and buy troops to based on the field. So if you're playing one, you probably place it right here. This will, and then you will click on yes. And then, so now you will buy a troop and place in field. So for a second player, I will disseminate. So this will be the second player. Okay, so now the first player will move down. So the objective is to like hit the chest, and then chest will break, and then quitting the ETH, and then you can claim the ETH for reward. So you can only move at one space, and then cannot move when the one space. So if we try to do that, it will not work. So we'll put down to one space, and the second player will move up by one space, and then this player will move right, then move. Now second player two will move right. And then player will go down, and then player two will attack the player because you don't want that player to claim the chest. Now they will battle each other's. Hopefully it works. That's how it works. Then player will attack. So you battle each other until someone's standing. Is it working? Oh, that player won. Now player will now claim the chest. Well, he has to hit the chest down. So this one is what represents the HP. So each time you attack, you will do more damage to it. How it works. And yeah, so once you take down the chest, you will get the ETH, and then you can claim your ETH for your war. And that's what I got so far.
Awesome. What'd you do? So can we look at the battle code just for a second? If you happen to have the smart contract up, can we look at how you determine who wins in the battle?
Oh, well, I have like a grid, and then each grid represents the HP, and once the HP hits zero, it will like disappear. So here's my attack. If the HP is zero, then you will empty the grid and set the HP to zero, and then basically remove it from the field.
So it's fully deterministic. There's no random there. It's just basically you're going to hit them and do 1 damage, and the players kind of start with 2, and then when they attack each other, they kind of lose 1 at each attack. Cool.
Yeah, it's mostly a strategy game.
Fun. I like the legal move drag and drop too, where you, as soon as you click to hold, it shows you the legal moves. It feels like a chess game or something, which is also very deterministic too. So it's like cute chess for on chain. Good work, Codechef. Keep going. Keep making awesome builds.
Okay, thank you.
Oh no! Oh, there's your timer. Whoops, sorry. Okay, who's up next? I think irfanb. Irfan, are you? Oh yeah, he's out here. Irfan, you're up next. I'm saying it wrong every time.
I'm here. Yeah. So I got my private key leaked the other day, and then I figured out I wasn't the first one. Then it turns out that BuidlGuidl has its own history with interacting with flashbots. And then we had this flashbot bundler build that some guy named LCFR did, I think. And it turns out we have some previous builds as well. And mine is just the next iteration. And the primary focus of my flashbot bundler is going to be simplicity, because I've seen like people that cannot speak English, sometimes they leak their keys and stuff. So I decided to build something that is very easy to interact with. And let me share my screen to display. So yeah. I deployed the thing on Goerli for now because it's going to be cheaper to create a setup for demonstration. And you will also realize that I will enter a funding account and hacked account. So normally the hacked account would have 0 ETH in it, but I will tell you, like, the hacked account that I will be connecting won't have 0 ETH in it. It will have some funds, but I will tell you the reason why later on, and it's going to make sense. So this flashbot thing, they're running their own RPCs. And when you send a bundle of signed transactions to them, they will just try to include it in a block that is not displayed in the mempool, because they're operating on their own private RPCs. And so that's why you can fund the hacked account. And then with the fund that you sent to the hacked account, you can trigger some recovery transactions to recover some ERC20s, 721s, or do any other call that you want. So yeah, I think that was a nice intro. So I will be using my own account for my main account for funding. And then the hacked account, as you see, it's not 0, but yeah, I'll explain why now. And when you get in, I tried to keep it as simple as possible. So so these must be covering all of the, like, most of the regular cases. So if you have some ERC20, 721, 1155 locked in, you can use this. You can use this build, or you can do a custom call here as well, which we will be demonstrating in a minute. And there are these contracts that I deployed on Goerli, and let's say, like, we have 2 ERC20 contracts, one NFT and one 1155, and we have some locked assets in them. So the only thing that is required here in this interface is the contract address, and I'm automatically fetching the balance. Of course, this can be made more flexible, but I'm trying to simplify things. And when you hit add, okay, I'm creating this basket of transactions. And the reason why I'm doing it is, if you look at the previous bundlers, what they do is you need to switch between the hacked account and to the funding account just to sign a transaction. And then if you're trying to recover multiple assets, you need to do it multiple times. But I abstracted them all away. And to be able to do that, I created this notion of transaction basket. And without touching the network or MetaMask, first we're crafting the transactions. We just added this ERC20 recovery transaction here, and behind the scenes, it created the transaction to be signed. And then similarly for NFTs, let's put this here. You will realize that I will be adding 1 transaction per NFT, but we can also deploy an additional contract so that we can get all these done with 1 call. But I lack this for now, so I will be creating separate transactions for them. And then for ERC 1155s, the token ID is 0 and 1. They belong to the hacked address, because this is how I set it up. And the nice thing is, when you complete this, oh, this is quite nice. Sorry, quite big. I hope we will be able to cover this, but it pre-calculates the total gas, and with a little overhead. And I'm doing this because when you're interacting with flashbot bundlers, either you do it programmatically and then you can debug it. I think the flashbot backend exposes some APIs to debug why the bundle failed, why it was not included and stuff. But I didn't include any of them here because, it's for beginners. And that's why I'm overcalculating the gas. And let's also try to add a custom call. Well, the custom call is also going to be an ERC20. So first you put the contract address here, and because it's ERC20, we will also add the function, well, it says ABI, but it's function signature. We will be also adding the transfer signature here.
And you're going to type it out. Here we go. Dang.
Yeah.
Nice.
When you type it out, it automatically renders a form. And then I will be transferring to my own account. And I know the balance is 10, but we could query it from the other screen. Let's add it. And yeah, they're all listed down here. And this is the estimated total gas. And then after this point, when you hit start signing, well, it's gonna show up some models and try to direct the user. So it first told us to go to the funding account. Yeah. And then when I could actually place a hook, and when the user switches accounts from MetaMask, I could automatically detect that, but I think I forgot to do it. So you need to manually close the model. And then, yeah, first it will want you to switch to Flashbot RPC, and then we need to do that. And after that, it will automatically prompt the signature thing. Well, I think the aggressive also works sometimes, but with the deal with the flashbots is that you need to bid really high, higher than the validators, because there's some competition with the flashbots, and white hat recoveries is not the only use case of flashbots. So what is recommended is you go to the advanced tab and then you bid really high, like I don't know, I've seen that increasing gas limit sometimes helps. I don't know why, but I'll just go ahead and do this 50,000. I might be wrong, but I just saw this work, so I will just do it anyway. And then priority fee, we need to give like 5, 10. I'll go with 10 so that it works 100%. And then a max base fee even higher than that. I don't know the math behind these things. Just bid higher, guys. Just bid higher. And if it doesn't work, bid even higher, all right? That's the formula. And then let's save it as the default, so that because in the following rounds, we will be switching to the hacked account and sign all of these things. And we want to bid high there as well. And when you confirm, it will prompt you to switch to the hacked address, and you won't be able to close this. And at any given time, if you think that you messed up the state, just you need to clear the cookies. Well, yeah, I didn't build, there isn't a built-in mechanism to do that. So you just need to do that manually. But now I will be connecting to the hacked account. Okay, so now that we are here at the hacked account to sign stuff, I would like to say, okay, this Flashbot RPC is the Goerli Flashbot RPC. If you connect to mainnet Flashbot RPC, it's going to show that the balance of any given account is 100 Ethereum. So that the MetaMask, so that your MetaMask allows you to sign a transaction. But for Goerli, for some reason that I cannot find explanation for, they didn't do that. So I needed to put some Ethereum in the hacked accounts to be able to just sign these transactions. But don't worry, at the end of all these transactions, the balance of hacked account increases. So this means that if it started from 0, it would still be able to sign things, hopefully if the order is correct as well, which I assume is. And then we need to sign all these transactions from the hacked account one by one. Let's just do that very quickly. Because, at the end, we will wait some time, and the Goerli Flashbot works really, really slow. So I don't know what we should do while we're waiting. So yeah, when you finish signing, it's going to pop up a model. It's going to wait for 10 blocks, and this is recommended in the Flashbot docs, and this is why I implemented it this way. And yeah, so what do you guys suggest? Should we wait until this is...
Let's talk through it real quick, and then we'll just hand it off to another builder up next. I think Carlos is up next. So basically you're signing and bundling up all of these things. So first you have to fund it. So you create a transaction to fund the hacked account so it has enough for gas. Then you sign a bunch of transactions with the hacked account. Then you send all of that off to Flashbots with enough of gas, I guess, and then they put all of those into the block without them ever landing in the mempool. And this allows you to sweep the account of non-ETH assets that basically the exposed private key, basically when your private key gets exposed, it's probably sitting in some script, and the script is just trying to pull the ETH. It's not looking very closely at other assets to go steal. So you can kind of sneak those assets out. But we could definitely, so this is close to being mainstream, but you did a few things here. You typed in the ABI yourself, and you kind of had to do the contract addresses. I could see a next version of this basically being connect the hacked wallet, and you connect it, and then it goes and finds all of your balances for everything and prepares it. And then you just kind of sign everything, or I guess you'll have to fund it and sign everything. But I think we could do one more iteration on this in terms of making it even easier for folks. Cause I know some NFT bros that would never be able to navigate this UI. So it's close to being mainstream ready, but I think it's still almost like BuidlGuidl hacker ready. It's probably not mainstream ready, but this is such a cool build and such a cool technology to be able to use.
Thank you. I can definitely automate the balances, and I will definitely do that. So
Awesome.
Yeah, thank you for the recommendation.
If you do that, let's have a designer put a finishing touch on this, and maybe even have some small amount of recovered, like some kind of tip that goes to you, and maybe like a tiny bit to BuidlGuidl or something, right? If we make this good enough that it's customer facing and a normal NFT bro can get in here and save their ape, I think that we could definitely add a little fee on here and make it more available for folks. So good build, cool stuff.
That would definitely excite me.
Awesome. Awesome. All
Yep,
right,
who's
Carlos. Next? Carlos is up next. Oh, I saw me there for a second. Carlos, take it away. Man, Carlos, I wish we would have hung out more in Paris. Sorry, I was all over the place. I saw you there a little bit, but we should have hung out more. Take it away, Carlos.
All right. Hi, guys. I want to introduce our project at ETHParis. Me, Shiv, and Olga, we built Omnichain Governer Standard. So a motivation for this was that recently I have run into many Omnichain projects. And yeah, I was thinking that this is going to become something big in the near future, Omnichain, multi-chain things. So I decided to come up with a Governor Standard for Omnichain. And it's basically a set of smart contracts that people can basically use. And for example, you can have a governor, you basically have two types of contracts, the adapter and the main contract. And then you will deploy your main contract on the settlement layer that you want. For example, in this case is Polygon. And then you will deploy adapters on the side chains that you want, for example, Binance or Ethereum. And then your users, they don't need to hold tokens in Ethereum from your DAO. For example, you have your DAO in Polygon, and then you are issuing, let's say, airdrops or something like that to your users, all in Polygon, but they can actually come and delegate votes from Ethereum, and they can also cast votes from Ethereum, and the same thing can happen from Binance Smart Chain. So that was what we built. Basically, it's a set of smart contracts that you can just go and import directly. For example, this is our repo. There's this example, it's called Footy DAO, and then basically you can just import the multi-chain governor kind of like standard, and then you will have all the features, all the functionalities ready for you out of the box. And then there is also the governor adapter here. And you will deploy to side chains. The same thing, you just inherit, and then you're good to go. And then one cool thing that we had at ETHParis is we had another layer of security provided by chain-link functions. So basically, chain-link functions were allowing us to set different proposal states across different chains and also read those states from different chains. And yeah, that was an extra layer of security for the voting process. And I cannot show a live demo, but I'm gonna show like a video because it's a cross-chain transaction, so that takes a while. So I'm gonna just like show the video that we had from the project. So basically, for example, there is this set of proposals, and then these proposals are in Polygon. So your DAO is in Polygon, and then what you're gonna do is you are going to connect. I'm going to get some tokens, and then I'm going to delegate some votes. And I'm gonna do that and go early. As you can see here on the right side, I go to go early and I delegate some tokens. And I'm just gonna wait until it processes because what we used this time was set a chain, and it's basically built on top of layer 0, similar to Axelar, and then they are gonna bridge your transactions to the other chain. So you have to wait for that. And then yeah, it happens, and then it was delegated also in Polygon. once that happened, then I can go and I open a proposal. I'm going to do that proposal. I'm going to open it in polygons. I'm going to change the chain over there in Scaffold-Eth, and then I'm going to submit the proposal, and then proposal appears there. Everything's in Polygon. But then I can go to Mumbai. I can go to BuidlGuidl, and as you can see, I'm in BuidlGuidl, but I hold tokens in Polygon, and then I can just vote for this proposal, which is in Polygon from BuidlGuidl, and I'm going to vote for it. And then the transaction will be executed. And I would just wait for it, and it will become 300 at the end. So I basically casted a vote from another chain to Polygon, and that's basically the project. The core of the project was the interaction with the Zeta chain and trying to build the standards. I think it's something that we can still build more, because there are different protocols and projects coming out, like Axelar. There's also CCIP from Chainlink. They use a different technologies under the hood, but at the end of the day, the interactions and the way you integrate, it's very, very similar. So this standard can help you build your own Omnichain governor in the future.
Is win anything? What were the prizes? Any sponsor prizes or anything?
Yeah, we got 5,000 from Zeta Chain. It was a good prize, and we had a lot of feedback from them, good feedback from them, because they thought it was very technical on the smart contract side. And then we had push protocol, and then we also had chainlink functions, and they also loved the way we use chainlink functions in the project.
Great.
So those three. Yeah.
Today I learned about Zeta chain. I didn't even know that existed.
Yeah, it's
Awesome
very similar
build,
to
Carlos.
Axelar. Yeah.
Great.
Yeah.
Great work.
One cool thing to mention is Shiv did this multi-chain version of a Scaffold-Eth, so we can basically choose the chains that you want in your Scaffold-Eth, because a Scaffold-Eth now it's limited to only one chain, but in this one we can connect to different chains, and this can be coded on the directly on the Scaffold config in the repo.
Love that. Oh man, I have a light freaking out above me. That's awesome though. It's cool to have Shiv, a Scaffold-Eth 2 builder, like kind of assisting you too, and being able to pick out some of these features and add them. Next time someone comes to me and says, I want to build a bridge that's going to have multiple networks, how do I do that in Scaffold-Eth 2? I'll be like, yo, go check out Carlos's build. Actually, I'll probably be like, go talk to Shiv. He knows what to do from here. Okay, awesome. I think we have Tam up next. So Tam does a lot of work on the Punk wallet and getting it up to man, I have like a light freaking out. Oh, it's smoking now. Oh man. So Tam, you are up next. I think we have like, is it gassless USDC transfers in the Punk wallet? I think. I'm excited to see. Take it away.
Yes. Hey guys. So what I'm going to do is create a new account, and I will try to send some USDC on Polygon and transfer it back without using the native Matic token. So I hope it will work. This is a new incognito window and the new Punk. It shouldn't have any funds at all, not Matic, not USDC. And I should be able to switch back to this. Oh, I forgot to copy. So I copy this account address, and I will send 1 USDC. Yeah, actually, we can also send some USDT or DAI or any ERC20 tokens.
That support the Paymaster system, right? Like, I don't think DAI lets you do a permit, but does it allow you to do Paymaster and gassless stuff, or is it just USDC?
Nah, actually, it's not Paymaster. That's the ZK Sync stuff. So it's a different style. Yeah, it should have arrived.
Hooray!
And, yeah,
one gassless
and I will just try to send it back. So
this is the moment of truth. Like, some of the worst UX in Ethereum is that you have to first have a wallet with a seed phrase and then have ETH in that wallet So you have to have a seed phrase, have it protected, then onboard yourself through some other ramp and send money in. And then finally you can interact with the network. So when you can get around both of those things with a burner wallet and then gasless transactions, all of a sudden this user experience, this whole whole world will open up to users when they can just get in here and start making transactions and kind of interacting with some app without having to have all that stuff.
Yeah,
looks like it went.
And, yeah. So the trick is that the transaction was paid with this relayer account. I call this relayer account. This account has some matic, which should be, so $1 should be enough for about 100 transactions, which is pretty cool. So Polygon is quite cheap. And it's not the paymaster stuff, but USDC actually implements this transfer with authorization method. So instead of sending a transaction, we can just sign this transfer message. And if it's recovered properly, then we can execute this this function with any account. That's the trick.
Awesome. Okay, so the trick is you sign a message. It's kind of like going back to old school like meta transactions. Basically, you sign a message, and then that message settles to the USDC contract itself, which is using EIP 3009, and then you have some intermediate kind of relayer that you have to keep stocked up. I think that's one little gotcha here is if you want to run a gasless burner wallet event, you can set all this stuff up. You can fork the Punk wallet. You can take exactly what Tam has built here, but you are going to have to spin up some address and then fund it and keep it funded, and it will pay for all of your users' transactions. Am I saying that correctly, Tam?
Yeah, exactly. So this is how it works at Punk wallet. So basically, we just sign this message. I'm using ethers, so this is the message we have to sign. And then I execute the transaction with a different relayer account. And one more thing, that this is USDC, so only USDC implements this one. But tokens on Polygon also implements these. It's called native meta transaction stuff. So this is quite similar. You can sign this message and execute the transaction with a different account. So with this, I think we can also send DAI, USDT, and probably any tokens on Polygon, any ERC20 tokens on Polygon.
I mean, technically, you could like do any smart contract interaction, right? Like, what if I signed a message to make a transaction to register an ENS on some side chain or like a name system or something like that? Could that? It doesn't have to be just transfers, does it? It could be any transaction.
No, it could be, yeah. So
Cool.
This is quite
like
a general one
data.
because
we
have the core data here.
And if you know a little bit of history, if you go to nifty.inc, Nifty Inc. is using a system. I think it's not meta transactions. I think it might be a paymaster, but it's a very similar thing. You can basically go to Nifty Inc. and you can paint something, and you can use a burner wallet, and you could say, yes, I want to ink this, and you basically just sign a message, and that's all you do. And that message goes to a relayer. The relayer puts it on chain. We at Nifty Inc. pay the gas for you. It's on a side chain, so it's cheap. But this user experience, I think Eco just released the new Beam wallet, which is also using this same stuff. It's using a smart contract wallet on top of all of this stuff, but smart contract wallet with a burner wallet with gasless transactions. We're getting so close to like being almost mainstream ready here. So very exciting stuff. Good build, Tam. Good stuff. And you guys, anybody out there, you can go fork this. It's just at punkwallet.io.
Yeah.
I'm really sorry. Can I ask a question?
Yeah.
I really couldn't
Sure thing.
understand what is the difference between Paymaster and, I don't know, maybe Byteconomy SDK's implementation and this one. Actually, I couldn't understand the difference. These are different things or same implementation?
Different. Actually, I have a Paymaster example as well. So that's for ZK Sync testnet, and the Paymaster there you can do any sort of logic. So this paymaster actually requires like 0.1 USDC to cover your transaction. So if you have, I don't know, 5 USDC, you cannot send all 5. You can only send 4.9, and you have to pay 0.1 USDC to the paymaster, and the paymaster pays for the transaction with ETH.
But from a high level, all of these are the same concept where you're using an kind of an off-chain wallet to sign a message, and that doesn't go on chain yet. It goes to some other third party, whether it's a paymaster or a relay or whatever the name for it is. But then that thing is taking that signed message and somehow incentivized to put it on chain for you, whether you've paid them on the side or something like that. So it's basically the same concept, though. It's a signed message that then is EC recovered within Solidity.
Yeah, I think we could even sign messages like without internet connection, which could be interesting.
Thanks so much for the answer.
Awesome. Awesome stuff. Okay, I think Bill Bodell is up next. Take it away.
Yep, Bodell. You got it in there.
You got the bow tie too. Oh, whoop, we'll have to steal the screen from you, Tam.
Okay.
There we go.
Cool.
Double bow tie.
All right. Yeah, I wasn't sure. This is my first bow tie Friday. I wasn't sure if everybody wears bow ties or not. So.
Luckily, no, that would be embarrassing.
Yeah, well, I came prepared just in case.
You got to look like a dork. Yeah, exactly. All right, take it away.
All right, so it's fairly simple demo, I think. I'm working on a hack for ETH Toronto, and my target audience is like farmers and like foodies, not crypto native. So was looking at on-ramps for onboarding people with social login, email, that kind of thing. Posted in the Scaffold-Eth channel to see if anybody had experimented with magic or Web3 auth, and Austin suggested I do it myself, so I did it myself. So this is just going to be kind of demoing the different ways to log in with Web3 auth. So added a extra button here in the Rainbow Kit modal that will pop up this. We went with Web3 auth over Magic for now because it supports more chains. I'm not going to continue with Google login because that would show everybody all my email addresses. So we'll see logging in with Facebook. We can continue as Bill. And then it's probably going to ask me to set up multi-factor. Nope, it doesn't. So one of the things that I really wanted to get out of this was instead of displaying like a blocky and your ETH address, which can be a little off-putting to normies, wanted to show your name and maybe a profile picture if it exists on your social. So we got that in there. And yeah, gonna dox myself on a few more accounts here. So come back in here, log in with Twitter. All of these work kind of the same. One of the challenges when I was following along with the Web3 auth documentation, it seemed like it was not possible when using their WAGMI connector kind of plugin, which is how I'm doing this. It was not possible to call a lot of the core functionality of the Web3 auth instance itself, which includes get user info, which gives you this kind of information, your name, email, profile pic. So on the back end, took a lot of this code from the examples from Web3 auth. So you're creating a config for the chain, creating this Web3 auth instance, which is where a lot of that functionality exists, and then there's some configuration for the open adapter login, and then finally you use that Web3 auth instance to create this Web3 auth connector instance. And the example I was following along with, this just returned the Web3 auth connector instance, which doesn't give you access to those extra features. So I had to tweak it just a little bit to return both the connector instance and the original Web3 auth instance there. And so then I went into the WAGMI connectors. Web3 auth connector instance is new, all new code. WAGMI connectors is what was creating the WAGMI connectors with all the wallets that you can use. So this is where I added that new group and the Web3 auth connector instance. And then I'm calling that that function here to create the connector instance and also grab the Web3 auth instance as well and export both of those. And then just in the Rainbow Kit custom connect button, added a little bit of logic to get the user info and store that, and then tweaked the login info a little bit, or the login button a little bit, so that primarily once you're logged in, this version of the button here, it's going to for the blocky avatar, if we do have a profile picture, we're going to replace the blocky or ENS avatar with your profile picture. And similarly, if we have that user info, we can display a name instead of that display name. And we could also, let's just see what else is available in that user info. So not all of these are going to be all that useful for this, but I did experiment with displaying an email instead. And there's a whole bunch more that you can kind of tap into, not just with the user info, but there are other functions that you can call on that Web3 auth instance, like authenticate user, which could be useful, and all this other good stuff. And so wanted to contribute this back to the Scaffold-Eth community as kind of a starter kit. So I did that, opened up a pull request, which is over here. Would love any additional kind of feedback over there, in terms of what else would be helpful for Web3 Auth Connect starter kit. I might also do a magic version. One thing that is a little obnoxious is when I first launched the app, I think it's always going, well, if I'm not connected, it's always going to pop up the Web3 auth pop-up right away, which I don't want. So if anyone's got any ideas how to stop that from happening, let me know in the PR. But
awesome, good build. I love the extra touch of using the profile image. I think when I connect to my Facebook and I see my Facebook picture, I think that's just a really nice touch. And the code wasn't that hard for you to do it, but it's like one of those things that I really appreciate when you see it. I think that you're probably not wanting to PR this straight into main Scaffold-Eth. I don't think Carlos is not going to allow that. But what we want is a starter kit, right? We want a branch that people can get to and find and use and fork.
Yeah. I just couldn't create the branch on the main repo myself.
Yeah.
Feel free.
It really doesn't even need to be in the main repo. It just needs to be available somewhere, right? We need to have it like on the builds. I don't know exactly how we do build discovery. This is kind of a trick we'll have to figure out, but good build. Let's figure out where we put it so the next person who comes along who wants to do social login can do so.
Yep.
Good build.
Perfect. Thank you.
Awesome. All right. Next up is Toady, I think. McToady, are you out there? You got your node modules cleaned up?
Hello.
What do you got for us?
Can we hear me?
We got you.
Okay, I tried to set things up and accidentally added some node modules that broke Scaffold-Eth entirely, but I managed to delete them and re-download. Hopefully we're in business. But yeah, let me get us, we'll start with some code. But yeah, so what I've been working on is kind of like a playground environment for scripting and like playing with specifically dexes and like arbitrage trading scripts. I can't say that. But yeah, so on mainnet, obviously, if you like SushiSwap or you like Uniswap or any of the other Uniswap clones, you can trust when you make a trade, like you're getting a decent price. Like you don't have to check every other DEX to see like, oh, what if I get like 20% more ETH for my USDC on SushiSwap or cows. Well, I don't know what they're called. But yeah, on some other decks. And that's because there's bots in the background where if the prices do get out of hand, they'll arbitrage those prices to make sure everything's even. And obviously that's not something you can take on as a dev, as a builder. You can't like go and fight these like super optimized bots that are running their own nodes. So I wanted to build like a kind of playground, like scaled back version. So people can learn the basics and then maybe they level up and they are trying to fight the big scary bots. But yeah, I wanted somewhere where you can play, splash around, and you're not in danger of like losing all your money. So yeah, what we've got here is just, there's 3 contracts. Contracts are here. So yeah, let me make this a little bit bigger for you. Okay, perfect. So yeah, we've got just, this is a bog standard ERC20 token and 2 of the Scaffold-Eth dexes. You'll be familiar with these if you've done the speedrun Ethereum stuff. The
With
only
slippage
difference,
protection? The
only
oh,
difference is yes,
you're getting to
there
it.
is slippage protection in these. So yeah, 2 dexes, slippage protection built in. But yeah, other than that, very simple dexes. And also, there's in the background, you can run a script. I won't go too far into this because I know we're speedrunning today. But yeah, basically I have a script that just makes random transactions to the dexes. So yeah, I think you can see here maybe. Yeah, it just picks a random size and then a random direction. So one block, it'll buy 5 Ethereums of the token. And then the second block, it'll go to the other dex and it'll sell 10, et cetera, et cetera. So yeah, it just makes it seem like you've got real traders existing in your local chain. And then where the fun part comes, your job is to kind of balance this out. So I built this. There's another fork version where none of my like ARB scripts or the ARB contractor there, where you can go and try and make your own scripts and can probably make one that's significantly more efficient than mine because mine kind of sucks, but works. So yeah, we have just a general script that runs through and just looks at prices and tries to, if the price on one dex is higher than the other, it tries to make a trade. If it fails, then it fails, and then tries again the next block over and over again. And I'll show you, I did some React today. It's kind of disgusting, so don't look at it.
Ooh.
But I did some React, and we have errors, but we're ignoring the errors. But yeah, so this basically, this tracks the trades that are happening. We've got the 5 most recent trades that have happened. So yeah, some ETH to token to ETH, and this is Dex 1. I was struggling. I was trying to get live prices, and that's what broke my Scaffold-Eth, so I've deleted it. But yeah, the prices should be here. And here you can see on the right is my bot. So it looks like, I can't tell what block we're on now. I guess it's been a while. Block 280 something was our last ARB successful. And now it's like block 400 and something. So yeah, our bot's not doing great work. But you can see here, it's attempted 50, well, there's been 53 ETH of trades, and it's made 1.9-ish ETH. So it's making a profit. So that's what we're here for. But yeah, that's just, go away. Oh no, we had a new one. Here we go. Block 461. We had another successful arbitrage. So yeah, that's just my fun build that anyone can fork. And as long as there's like a few event names in my contracts and the contract names themselves, if you keep that all the same, then, and the rest can be whatever you want, and you can run this and get this disgusting UI that I'm going to make prettier, but yes. So yeah, I want some people to play with it and try to make the most efficient trading bot in the world.
Awesome. I think we're even going to use this for some games and stuff. We have some like fun games where like I did this emoji coin exchange a long time ago, and it was just one contract and you could trade against it. I think it's time to do something similar, but with actual dexes that we control with our bots, and McToady is kind of laying the foundation for that here with some of this early stuff. Nice UI here. Very, very nice. I feel like this is like you work for the government or something looking at this UI.
This is basically an Excel spreadsheet, but it's been placed onto a web page.
Awesome. Okay. Good build, McToady. Looking to see that continue. Is Alex still here? Let's see. We're kind of running late. Let's see who is still around. I don't know if Alex is still on. I don't think he is actually. Okay, if Alex is out, then next is Damu. I think Damu might be our last presentation today. Take it away, Damu.
Okay, hi. I will share my screen and a link in the chat.
Oh, that means it's interactive. I know that. I know that sign.
Can you see my screen?
Yep, we've got it.
Okay, so we are working with Carlo on different kind of wallet. We built one for event that was used at ITCOM Montenegro, and now we are building one wallet to interact with the people when giving a talk. If you enter the link that I share in the chat, this is a wallet that the attendee can check in. You can check in here. You are signing a message in the background, and here you see my new. Can you see my new tab?
Yep, we've got the new tab.
Okay, so here we can see all the check-ins from the attendees, and you can set an alias too. Here you can set an alias, and now if I go there, now my address is replaced with my new alias. Here is Carlos. So
very nice.
After, yeah. So I'm trying to go fast. And after all the attendees have check in, now we have some questions that we can ask to the attendee. This is the first one. If you scan this QR code, you will go to the answering page. And now the question is open for responses. The answering space is this one. So I can answer this question. I am really bad. Carlos answered that the question, and some second this me too. Then I can go to reveal and reveal the answers. This is and I can see all the attendees that have a right response answer. And here, here questions leaderboard. Can see all the attendees that have more than 0 score, and it will be ranked in this leaderboard. So to finish it, I can open the second question. Question number 2. We can answer it. We can check if member lover answered the question. I can reveal the answer. All good. And here in the leaderboard should appear all. Oh, Austin. This is the leaderboard from all the questions. Well, the question are loaded from a a JSON file, so we can add all the questions that you want. Well, this is what we have for now.
Awesome stuff. And just to give a little oh no, go ahead.
No, all the information is saved in the key store that from BuidlGuidl that is a Redis database, and all these interaction are signing message when you save your answer in the background, you are signing a message.
What was the storage again? Okay, so this is, we're using Scaffold-Eth 2, and that has, if you want to make a backend, you basically just make a route within the API folder. But then there's some storage later. You called it something DB.
Yeah, KB. This is a BuidlGuidl KB that is a Redis database. Redis.
It's for a key is like key value.
Key value. It's like a key
yeah.
value store, and Redis is the classic key value store. Okay, cool.
Yeah,
awesome.
Exactly.
Awesome. Okay. And do you have to run that infrastructure somewhere, or does like Next.js take care of it? You just say, yo, Next.js, give me a key value store, and then you point your app at it. What's that look like?
Yes, it's a new feature from BuidlGuidl. You get this database from BuidlGuidl and you can use it.
Awesome. Awesome. We need to do just like a good Scaffold-Eth 2. Here's how you do a signature backend. I feel like a lot of good Web3 apps will start with just signature-based stuff going into a database like attestations or answers and stuff like that. So to give a little bit more context on this, I've been giving like lots of presentations, and when I go to present in front of a class, I'd like to have like an interactive thing. And so I think what we'll do is we'll start out with like, here's a QR code, shoot your phone at it. Then you land and you check in, you set your name. And then one quiz that I could ask is more like pick a random number between 1 and 10, and then 1 and 100 and 1 and 1,000. And we start teaching people about how private keys are really large numbers. So this is all just like laying the groundwork for being able to have much more interactive talks. But eventually we'd like to do this like at events and have like a great big game that's played. And this hopefully will integrate into the stuff that McToady just showed, where we have dexes. So people check in, they get ready to go. And then maybe I drop them some gas and whitelist them into using some dexes, and then all of a sudden they're trading shitcoins and stuff like that. But it all starts with these signed messages and this kind of interaction where you can just point your phone at a QR code and be part of the thing and be checking in and be playing. So good build, Damu. I'm excited to extend this and turn this into some interactive games and stuff.
Thanks.
Awesome. Okay, I think we did it. I think that was a Bowtie Friday. Thank you all for coming along. Thanks for being here. Great presentations, y'all. Good bow tie. I always feel bad when people wear bow ties because you definitely look like a dork.
I look like a cool dork.
Yes, a cool dork. Exactly. Awesome. Great builds, y'all. Happy Bowtie Friday. Thanks for being here. See y'all later.
See you. Bye-bye.